to the Tech Trends podcast, where we discuss the latest manufacturing, technology, research, and news. Today's episode is sponsored by Modern Machine Shop, Made in the USA podcast. I'm Ramia Lloyd, and I'm here with...
I'm Alyssa Davis, the digital community specialist.
I'm Steve Lamarca, AMT's technology analyst. Not the only one anymore, though.
I am Benjamin Moses, the second most awake person here. Everyone is really sleepy this morning.
I think you're the most awake person.
Yeah,
Probably.
I don't know who's beating me right now.
I've gone through 3 cups of coffee, so it's all good.
Nice.
Yeah,
Okay.
understandable.
Just
then.
prepared.
Just prepared.
Cool.
Alyssa,
Yeah.
I hear South Tech is happening this week. Tell me what
Yes.
you're excited for.
Well, I've never been to South Tech.
Yep.
I've only actually ever been to East Tech. So this is my first time.
Same.
Yeah.
Where is South Tech?
It's in Greenville, South Carolina.
Does that make sense?
Fun place.
Yeah. And our hotel's like right on the water. It's going to be really nice.
Greenville's really pretty.
I've never been to South Carolina. And it's like one of the few states I have never been to in my life. And so I'm really excited. I've never even had like a layover there or anything.
Everybody in South Carolina is so polite and super nice. And you're going at the perfect time of the year, because any other time of the year would be miserable.
It's still going to be like in the 70s and like low 80s.
It's going to be pleasant out there.
It'll
Yeah.
be nice.
Yeah.
Super white.
Well, I mean, I went to a John Mayer concert on Friday. I get it.
Like South Carolina is how I pictured when Lavelle Crawford during his bit talking about Aspen, Colorado. He was like, there is one person of flavor there, and when you show up, they're just going to be like, "Welcome to Aspen. Now it's my time to leave." That's South Carolina.
Yeah. I think it'll be really cool. I know I'm going with our membership team.
Yep.
And so they're probably going to go see some members and be able to introduce me to some people. So, I'm excited. And then a couple weeks I'll be going to West Tech too. So I'm gonna be all over
So
the
you're
map.
seeing all the tech.
She's a traveling
I'm
girl.
going to all the. It doesn't hurt that my boss is currently laid up at home with
Got a feeling.
on painkillers. So
It would be interesting to see, because these are the SME regional events that we've partnered with.
Yes.
And it is cool to see, the different kind of focus in each of the areas.
Yes.
So I definitely want your hot take after going to these 2 events to see, what's kind of different between the 2 areas.
yeah, I got when I was at East Tech, I got this. Our booth was right next to this this machine that was using laser to cut shapes out of metal.
Yep.
He would just find stuff on the internet and put it on the screen, and then it would cut it out for you.
Cool.
That's so cool.
I love that.
Yeah, and so Leah, who also works here, we both have a set of little dolphins
Oh, cool.
that he printed for us, because they would print it and they put it on the floor and they're free to take.
Yeah.
So I have that, and then I've also got a butterfly that he printed.
That's cool.
It was really cool.
Yeah.
So I'll be interested to see what kind of stuff, because I'm a hands-on person.
Right.
I love that a lot of shows are they're literally like children's museums. You know, you just get to touch everything, you get free stuff. So I'm excited to see what they have at South Tech, because East Tech is such a big show,
Right.
and I know South Tech's going to be a little bit smaller, so it'd be interesting to see what they have there.
Soapbox. That's all I want out of the manufacturing industry is somebody with a laptop and a machine tool. Just have people come over who they want to demo to these people their machine, and just pick something on Google Images. Or
That's literally what he was doing,
realistically, grab CAD.
Right.
Get me a CAD design, and this is why I have trouble with the cam companies all the time. Is because I'm like, no, don't show me something that you already have saved to convince somebody like me. Go on Google. I want you to open a new tab right now. Go to GrabCAD. Pick anything you want, whether it's a Pokeball or a bottle opener. Get something on GrabCAD. GrabCAD and download it and turn it into G-code. I want you to do it in front of me right now. You have 5 minutes. And they can't. That's literally all I want out of this industry.
Yeah.
And that is useful. So the hands-on experience. So to your point, Steve, the user workflow. But to your point, Alyssa, so if I'm going from a water jet to a laser cutting machine, it's being able to see the hands-on experience of, what does the surface finish look like? What are the edge prep needed? So being able to just physically feel it, that's very valuable for a manufacturer that's either replacing a piece of equipment or just looking at new technology. So
Yeah. Well, my butterfly is very sharp.
Yeah,
It's got a couple of really sharp edges.
It is not deburred. When it's
We
coming
do
fresh
need
off the
a
machine.
deburring tool
Yeah.
in the office, just so you know.
We don't have one?
We don't have one.
I got a couple at home. I'll bring
Okay.
one in.
But maybe I'll bring back some knickknacks from South Tech, and I'll bring back all the info.
Yeah.
Because I'm really excited because
Yeah.
I've only, like I said, I've only ever been to East Tech, and now I get to go to all the techs this year.
This is
'Cause
awesome.
I went to Hughes Techs earlier this year too.
Yep.
So
I love that Houston has their own tech.
Right?
yeah. Well, I mean, I love that it's called Hughes Techs.
Right.
I just like how that sounds.
Yeah.
They're really fun. Like, they should do that with more cities.
Well, they could also just call it like they could do it at
If there was Chai
They could do
Tech?
it at any other city in Texas, and it could just be called Texas Tech or Tex Tech.
Oh,
You know,
Tex
I
Tech?
do kind
It
of
still
like Tex
works.
Tech.
Yeah.
That sounds fun.
SME, you got my number.
Alliteration.
And I do like Texas design and manufacturing because every city or area has got their own specialty.
Yeah.
Like you have the Fort Worth area, you got Houston, you got Dallas, you got like Galveston even. They all have their own like little specialty within like oil and gas, heavy industry, or defense even out of Fort Worth or aerospace.
They had a big like Bumblebee from Transformers, but it was built all out of like different like manufacturing parts.
Yeah.
And that was
so
like the
cool.
big piece when you walked into the show floor at Hughes Tech, so that was pretty cool.
Industrial art pieces are so awesome.
It was, I mean, I have pictures of it. It was really cool.
I have a question for you, Alyssa.
Yes.
Let's continue on the topic. I heard
Yes.
you got a bee update.
Yeah, I do have bee update. So my NASA bees book. So I found out that the reason why I didn't realize that like I didn't see anything about the bees is because on the back of the book it calls them robo bees or robot bees. So they're not bees, they're robot bees. I haven't gotten to that part in the book yet because obviously it starts in like the time of Aristotle and it's 50 major events through history of robotics and AI. So it starts with Aristotle and eventually we're going to get to the robotic bees. So the robot bees and NASA's use of them is going to be one of the major chapters. So that's where the bees are coming into play, NASA's bees. And it's a really interesting book because it's great for someone who's newer to the industry and a little more beginner like me. And it kind of just breaks down different like these events. It starts with like Aristotle and his use of like automatons.
Yep.
Wow.
But what's really interesting is that it also talks about how the people's fear of robots and automation taking people's jobs is literally as old as Aristotle. Like ever since automatons were on the books, people have been afraid that they're going to take their jobs.
That's amazing.
So I feel like if it hasn't happened in 2,000 plus years, it's probably not going to happen.
Or the other way to look at it, if people raise a concern, just move on. Stop talking about it because there's no way to placate this conversation. There's nothing you can say to calm them down. They're just going to have that fear.
No.
It's and it's interesting to think that like there's some things in society that never change, and it's interesting that that's one of the things that never changes.
Yeah,
is that
definitely.
people being afraid of robots taking their jobs.
Robot bees,
funny.
though, that's like, I'm not afraid of them. I feel like there's rationale to being afraid of robot bees, though.
It's like murder
Bees
hornets.
kind of scary. Robots, if you must, they can be kind of scary. Robot bees, though, let's take it easy.
Hey, but maybe that's what saves the bees.
Maybe this is what saves them.
Is the robot bees.
But this goes on to my follow-up questions. Who made the bees? Is it humans? Is it us? We're making these bees?
I believe so.
NASA?
I believe it's NASA. Yeah.
What is the purpose of the robot bees? Is it for pollination?
I don't know.
Or
I haven't gotten to
exploration?
that part in the book yet, so I'm keeping you updated.
I need to know more about the bees. Thank you. I
Yes.
appreciate that.
To be continued, Steve.
To be continued. This is going to be my running series throughout the Tech
And
Choice
is there
podcast.
robot honey? Or is it just like
Would that be
10W40?
oil? Yeah. Like the Tin Man. Yeah, so robot bees. Which, are kind of, when I picture them, they're very terrifying.
Right.
But I'm sure they're not. I'm sure they're just like, little tiny bit, like little...
It sounds very Dr. Robotnik.
Well, to be fair, there's a lot of organizations mimicking organisms into like robotics.
Right.
Right. Tesla's been doing that a lot with they have like a fish. They've got a bunch of different, not quite replicas of the natural world, but taking organic mechanics and see if they can mimic that. Like the hummingbird is a real interesting approach nowadays. A neat thing they're trying to get into. See if they can mimic, a flight through hummingbird mechanics. So
It's interesting, because isn't a hummingbird also like a pollinator?
I think so.
So are we just kind of trying to mimic a
copying
lot
all
of
the pollinators.
pollinators? I mean, which is good because apparently they're dying out. So like we need more of them.
Yeah.
But
Yeah.
that's interesting that like those are the things that we're choosing.
Yeah.
Because they're two of the things that I think in some ways we least understand.
I think it's related to transport. So like underwater, copying like a stingray and how those things, dolphins and how they move through water instead of just using a prop. So there's, I think the exploration of efficiency, if an organism can do it one way, is there a way to mimic that and improve our efficiency in robotics? On that note,
Kind of like how the medical industry learned to make more efficient needles for injecting people with stuff.
Yep.
They studied the mosquito.
yeah,
You can get a needle that people won't notice.
I don't think that's true. I always notice a needle. I always notice a needle.
Have you seen the videos of like a trained like nurse or doctor jabbing a balloon
Oh my god,
and it doesn't
are you
pop?
talking about that viral
Those.
video?
How
recently?
crazy
Yeah.
is that?
Yeah.
Like
I still would feel it.
it's
Ben's
wild
like,
though because
no.
like you can tell it's like a
You're
dentist's
one
office.
of those.
I am.
Yeah.
I mean,
To be fair, when you see it, if you see it, you're gonna feel it.
Yeah,
Even if you don't actually feel it, you're gonna feel it if you see it.
You're actually like one of those concealed carry holders that's like, why do you have that? Are you scared? and they just like, not scared, bro. Not scared. Being scared has nothing to do with it.
no, I'm not scared of being shot or receiving shot. I just still feel it. Let's talk about injections. I mean,
I'm sorry, Ben.
Ramia, tell about say sponsor, please.
Okay. Tune in for Modern Machine Shop's Made in the USA podcast to explore manufacturing issues faced by companies making an intentional choice to manufacture in the U.S. Featuring commentary from OEM leaders, Made in the USA blends its nearly century-long expertise with a unique audio storytelling experience to shine a spotlight on the past, present, and future of American manufacturing. Find Made in the USA on Apple Podcasts, Spotify, and all major podcast platforms. Follow Modern Machine Shop on Twitter, Facebook, and LinkedIn.
Thanks, Ramia.
You're very welcome.
Steve, I hear we might get some equipment for free.
Oh, yeah. Okay, so test bed update.
Yep.
And I think this was true the last time we recorded, but the accessories for our new robot arm are on the way.
Yep.
Or at least as close to being on the way as possible. They are Mike Spaziano, my contact at Aegis, is making sure that they have everything in stock, and he's compiling all of them and making sure everything is present, checked off, and packaged before they ship it out. And this has been concerning to me because they're telling me all this stuff, and like I still haven't paid you.
You paid for the arm, just not the accessories.
This is America. You are providing goods to me with spectacular customer service too. Yep. By the way, in return for that, you're supposed to receive money, and I haven't paid anything yet.
Steve,
and
maybe he's expecting a read on the podcast.
maybe. But it's just weird because it speaks to our younger generation that likes to buy things off of the internet without talking to anybody. And I just even was like, oh, go to this website and just throw together your cart. Like throw together everything that you think you want. All of our information's there too. All of our supporting documents, marketing materials are on this website. And it's very much like the Amazon of robotics. I think I talked about their website on a previous episode. Very clean, easy to use. You just throw it in your cart. And then, we spec'd out the robot and all the accessories we want. Let's click checkout.
Yep.
And when you click checkout, it's like, you're going to be contacted by your local representative. I'm like, okay, that's great.
Not bad.
Fine. We did so close.
So close to buy now.
And now it's like, you're no longer a young person. Now you have to talk to people in the face over the phone. And that's fine. They're really good. Like, again, I mentioned before, exceptional customer service.
Right.
They were very friendly to me. Heck, they're packaging it up, and it may have been shipped by now. I still haven't paid anything. So that's cool.
Yeah,
I kind of got it for free. They're still going to collect soon. But, that's just my most recent adventure and experiences.
And we've been talking about this off and on, the buying process of manufacturing equipment still feels rather clunky. There's certain things that you could buy like right off the shelf that you can just hit the buy now button. And we compared this to like when Boston Dynamics released Spot.
Yeah.
You could actually go to the website and say buy now and, pay $70,000 and get a robot pretty quick.
Right.
And it still feels that in certain, I would say kind of niche markets, what we're trying to buy is fairly niche, but it feels like it's a clunky process.
As for buying directly online, like actually paying online, they're trying to avoid that because like for example, the same thing goes for like when you buy a Tesla. You don't have to go to a dealership.
Right.
They have showrooms in a shopping mall.
Yeah.
And they can help you buy the car in the shopping mall on your own phone, by the way.
Yep.
But they're sending you to the website.
Yeah.
There's something exciting and dare I say dangerous to spending a lot of money on a website, even though you're going to get that email receipt saying like your order's confirmed.
Right.
Like even though all this money is gone from your account,
Orders confirmed
we
for
assure you,
$50,000.
like we're in the process of getting you your thing. But thanks for the money. This is the total opposite of that. There's no danger to it. There's just, I don't want to say inconvenience.
Yeah.
They're like making sure, hey, you're gonna give us all this money, but we're gonna make sure you get what you want first. It's weird.
I mean, it's like
we're not used to it. I'm sorry.
Yeah.
no, we're not. And it, but it's like when I tried to cancel my Sirius XM subscription, you can't cancel it without talking to someone.
Oh yeah.
Like you
That's a
have to
headache.
talk to a representative in order to cancel it.
Yep.
You can do it over chat, which is great. But what happens is when you talk to them over chat, they're like, "Oh, we'll give it to you for $5 for 24 months instead of the $20 per month you've been paying."
Yeah.
And I'm like, "Okay, cool." That's why they do it. But like that's part of why I didn't want to cancel it for a long time because I was like, I don't want to talk to anyone to cancel this. I just want to be able to cancel it and never think about it again.
Yeah.
It's not something that our generation is like. The thing is, like, as a kid, I was great at talking on the phone. Growing up, I talked on the phone a ton.
Sure.
But if someone tries to call me now, if I have to even like call my doctor's office or call someone or something like that, I'm like, like hyping myself up for it. Like it'll be quick.
Yeah.
So you're gonna think about it all day,
and then
I
you
put
never
it
have to do
off.
it.
Yeah.
I think that's the underlying behavior is that if there's value add in the conversation, like if we're trying to call someone to solve a problem, I think most of us are comfortable with that. But buying something is not value add. Or you can chat, whatever.
Yeah.
Yeah.
Like, so going through the mechanics of trying to buy something, when you know exactly what you want, you don't need a consultation.
Yeah.
You know the end process. There's no added benefit of spending the time talking to someone. Like clicking buttons is so much of a faster process. I think that's the difference in kind of the generations of,
like when I
buying
bought
behavior.
my car, I didn't take it for a test drive.
You didn't?
I'm a psycho, I know. I like knew that's what I wanted. Like there's only one other conceivable option that scratches the itch that I want out of this car.
Right.
I don't need to test drive it because I know that the other options do not check off as many boxes as this one does.
Yeah.
This is the one I want. As for other vehicles that I've test driven, and I probably less than 10 in my life, 100% wasn't gonna buy it.
Right.
Absolutely not.
Yep.
Yeah, okay.
I wanted to drive it or ride it in the event if it's a motorcycle, just to say I did it and to see like how much greener the grass is on the other side. I was in no way gonna buy it.
Yeah, that's fair. And I think that is fair for myself too, because my test drive was more a confirmation as opposed to like it wasn't. There's nothing that could have happened on the test drive that would have said no, this is not the car you want.
Right.
All right, let's get into some articles.
There was something I wanted to say on that too. I lost my train of thought. Never mind. Let's go.
Back to NASA. I found an article talking about NASA tests 3D printed aluminum rocket engine nozzle.
Wow.
So this is kind of interesting on a couple of layers. Aluminum, exactly. So they're doing a couple of tests on this entire process. One is reducing the number of components. We've seen that a couple of times, back when GE Aviation was testing their 3D nozzle. So reducing the number of components and getting to a single piece. So as opposed to a massive assembly, reducing the complexity of the part assembly. The second is material. Their nozzles are very hot. In the video, they do a test fire. It's cool to see because obviously you see the flame coming out. But on the backside, they're cooling it, so you see icicles starting to build up on the outside. So both on, instead of using like super alloys that can resist the heat, they're working on improving the material capabilities. So they're using aluminum 6061, which is common, but a variant of it. They call it Ram 2, and they're using a bunch of different partners to supply this. So I thought it was a very interesting thought process on, one, they're trying to solve the complexity of manufacturing, but also look at new materials that they can, if you save weight on a rocket, that's huge. That's significantly more beneficial than like aerospace or anything like that. And the other takeaway that I found very useful here is NASA can't do this alone. They're defining like where the use case is. They definitely need industry partners. The article talks about several industrial partners that they worked with on this case, but they can't do it alone. So they're defining where they want to go, and industry stepping up to say, yeah, let's work on this together. So between industry partners and NASA leading the way, seeing a lot of innovation occurring on that front.
That's beautiful and incredible. Because I'm sure there's a lot of people like who've worked with rockets who are hearing that. Like, that's insane.
Yeah, it is.
This aluminum is gonna melt like American cheese on a skillet. like this is dumb. Why are we doing this? But if you think about it, rockets, which are our newest form of engines that we as humans have created, every engine that we've ever made started air cooled,
right,
and then went to liquid cooled. Like it started as a big, bulky, heavy thing that doesn't produce as much as it can out of the fear and risk of it overheating and parts failing. That's literally any air-cooled engine of any type of combustion or not. And then we went to air-cooled or water-cooled, meaning we have a cooling system with weaker materials, don't need as much material for the engine block. It's not as overbuilt because now we've got water going through it or some sort of coolant, refrigerant to keep it in operating temperature. And any engineer is like, you just took a beautifully simple system and ruined it by adding complexity to it,
right,
and adding another major component that can fail. And if it does fail, the whole system fails. So normally that doesn't sound smart, but we've been running liquid-cooled engines forever now.
Yeah.
In fact, they've almost entirely replaced air-cooled engines. A lot of high-performance computers now are liquid-cooled.
Yeah.
So maybe I'm not as excited about like the materials aspect of this, but I'm really excited that, wow, rocket engines are this mature now that we're liquid cooling them. They're not air cooled anymore.
Yeah, it's a fun video. You should definitely check it out. I like their hot fire test. Yeah. NASA does a good job on that.
They do really cool.
And so as like more of like a layman looking at it, I think for me, I'm like, whoa, like aluminum, that makes sense, because I always think of like aluminum foil.
Sure.
Right? Like when you take it out of the oven, you can still touch it.
Right.
Without it burning your hands. You can't touch the pan, but you can touch the aluminum foil.
Yeah.
So I'm like, oh, well, then aluminum makes sense because it has that property to it. I know it's like it's obviously like a variant of that type of aluminum, but it'd be I would assume it'd be much lighter than anything else that we.
Yeah, and that's what they're shooting for is just improved overall efficiency. So good on you, NASA.
To expand on that though, and as a counterpoint. Long before some of the food companies decided to wake up and realize that they're killing us, American cheese used to have aluminum as an additive to help it melt easier.
Oh, yum.
So,
yeah, I mean, the same in
materials.
Steve, tell us what you got for today.
Oh, today? So on Saturday, I woke up and found out that for like the first time ever, asterisk on LinkedIn, I've been professionally quoted.
Oh yeah, I saw that.
And I'm really pumped about it.
Yeah.
Like somebody thought that a little excerpt of the hot air that comes out of my mouth on a daily basis was actually quotable. But it was on an article that I want to share. Failing me. I still haven't found it.
I think you pulled it up on Slack.
Did I pull it up on Slack? Mm-hmm. Did I post it to Slack? Oh my God, I did. You're right. Thank you. 3dprint.com RIP 3D printing.
Yeah.
And then the dates 1987, which I'm glad they got that right. Disputable. Everybody agrees that it was in the 80s,
Sure.
but they don't know if it was in the 80s. I, didn't look that far into it, but I'm going with it. If somebody's willing to publish it in their article that's going to have their name on it, it's 1987. Good enough for me. To 2023. Complexity is expensive. And basically, they're like, this is not a clickbait title. Well, it totally is a clickbait title. The article might not be clickbait, though. There's a public service announcement basically saying that, like, this emerged technology, which is no longer an emerging technology, but it is an emerged. And I'm so glad that I've been saying that for years. Alyssa agreed with me today. And now there's an article out there.
Yeah.
But instead of just ripping into additive, which would be the easy way to do, I read the comments on the LinkedIn post, and they're very good. There's an excellent discussion going forward. The author of the article had posted it to LinkedIn, and that's where I'm reading the comments from. It's not like Facebook, YouTube, or Instagram comments that's just a cesspool of toxicity. There's actually a solid discussion going on right now between people who have differing opinions from the article and the author backing them up or agreeing with the person. It's a really cool ongoing discussion right now about the current state of additive technology. Is it dying?
Yeah.
Is it dead? Is it an investor's worst nightmare? Has it been an investor's worst nightmare? No, short answer. But it's just been really cool. And yeah, I commented. What did I? Now I don't even remember what I said. But my comment on the post was, just because a technology has successfully emerged doesn't mean it's been successfully integrated, which is additive's major problem right now. There's a whole what was the word that I used? Traditional, not trans. Traditional manufacturing industry that has been making the world go round for decades, if not centuries now. And it's run by people with very they've been doing this, and their pappy's been doing it, and their pappy's pappy's been doing it for hundreds of years now. This is how we do it. We're not going to change it. And then along comes this new technology, additive, which is hopped up on Star Trek's The Next Generation of Counselor Troy just being just hanging out on the ship and being I want hot chocolate. Computer, give me hot chocolate. And hot chocolate just materializes in front of her. They think that's where additive's going to go. And it's no, we've got a long ways to go. We've probably a few more centuries before we're there. But, I'm glad you recognize the baby step to that is additive. And these two industries have been headbutting, not necessarily headbutting, but they don't see entirely eye to eye, which is why we've got this excellent developed technology that is all things additive, and it hasn't been fully integrated into the rest of the traditional manufacturing workflow. And we're getting there, and we're much farther than I'm describing it right now. I mean, I just, I hate to keep bringing it up, but that recent Oak Ridge National Lab trip that I went on, I've seen how far additive has been implemented into the rest of the industry. But I think this guy's concern is just that, before I hand it over to you, is just that there's still ways to go. We haven't seen the returns that we wanted because we're not done yet. The technology is done. Now it's time to focus on business. And just in case you haven't realized this yet, we're in the business of making parts to make money. And
that's what I want to hit on two layers. I agree, definitely the integrations. If I have a workflow of a part that's being subtractively manufactured, that workflow is fairly robust. The CAD CAM, getting to post something on the machine itself, the inspection process. But the workflow of an additive part in that entire workflow,
right?
It's not there. It's you have to create an STL file still. You have to create two different languages to get to a finished product. Right?
There's a digital setup,
right? And it's broken a little bit, right? And that's one thing I still struggle with a little bit is the workflow of going from program to program is perfectly fine. I understand that. So from an analysis or going from CAD to analysis to something else, a lot of times you are exporting and importing files, but does that make sense, right? I feel like there's always a loss and risk of non-connected systems. And I think that's one of the biggest drawback that I'm seeing. And to your point of, it's not integrated, right? We understand the end use case of we want to improve our efficiency. We want better nozzles. We just talked about that. But the workflow from the product to the ideation, that workflow is completely broken between the different processes.
Right.
And the other side that you hit on definitely is the risk or the business. That the risk of the business side of it is still very high in additive, I think, because of the cost of equipment and the knowledge set to achieve a production level part. It's not quite there, and that's where we see a lot of consultants or companies being successful as a bureau as opposed to companies bringing in their own equipment first. So it's still a lot of ways to go, but a lot of adoption.
Yeah, we're getting there. I think additive is further along in the integration process with the rest of the manufacturing technology,
right?
Than this article lets off.
Yeah,
I mean, it's if you're still in the mindset in 2023 that how is additive not killing the game? They're always in the news. People are constantly invested in them. It's there's probably 2, maybe 3 companies, additive companies, that are actually making a profit selling machines.
Right.
The rest of them, their money came from investors that don't know any better and didn't talk to anybody smart.
Yeah, the market's tough.
I think instead of the hot chocolate thing, we should be aiming for the Spy Kids microwave.
That was the first thing I thought of.
What?
Okay, elaborate on this because you mentioned this earlier.
Have you seen Spy Kids?
No.
Oh my gosh. Well, then.
But I want to.
Okay.
Only because apparently my motorcycle's featured in it.
Oh. It's definitely a movie of its time. I watch it back now and I'm like,
it's dated.
Wow.
Yeah.
I think it was dated.
I saw the third one in 3D with the red and blue glasses.
Oh
the
my
first
God,
movie I
that
ever
was
saw
my
in 3D.
favorite.
But they have basically it almost looks like a military MRE. It's like that kind of packaging.
Okay.
And they put it on a tray in the microwave and she pushes a button and then it comes out as a Big Mac and fries.
Oh yeah.
And
wow.
and it's somehow the microwave makes it into this food, and so instead of the hot chocolate, we should really be aiming for the Spy Kids microwave, in my opinion.
That's really peak performance for me, honestly.
I put it in last week's tech report, and I'm gonna say it again, and I'm gonna say it until we have one at the office making me pizzas. But I want a 3D printed pizza. There's no reason that direct energy deposition and material extrusion on today's technology can't make me a pizza on a regular basis.
Alyssa, can you tell me once we get our pizza machine how a humanoid warehouse robot's going to deliver that to Steve?
Yes. Well, if he orders it from Amazon, that's how it's going to deliver it to him. So Amazon's been using robots in their warehouses since 2012. So they've been doing it since I graduated high school. And but they recently announced that they're going to start using Digit. That's what it's called, right? Digit,
yeah.
Yep.
Which is a bipedal robot that will be able to lift and move packages. So rather than just the little robots that go around the floor, this will be almost like a person walking around the floor and lifting things
Digit
up.
is the model name of Agility Robotics humanoid robot.
Yeah, and I know there's been a lot of articles that have come out about people's concern about does that mean robots are taking our jobs? And so it goes back to what I was talking about. It's a tale as old as time.
Yep.
People are terrified that robots are going to take our jobs, and it's well, someone's got to run the robots. Someone's got to watch the robots. Yeah. And Amazon has said their integration of robots has created a lot of jobs.
Yep.
But yeah, I mean when I was looking at because my Google alerts, I have robots set up as one of my Google alerts, which is very general, but it's great to get some good articles, and it was all just filled with the Amazon robots. Because that's that's the hot news right now and people are oh, well, the robots are already taking our jobs at Amazon, so it's just going to take more of them. And it's no, I don't think so. Right. I think it might, in some ways, it might kind of ease the burden of people working in an Amazon warehouse because they can let the robot pick up the heavy stuff and, save their backs. But,
and there's 2 observations along these lines that I was thinking about. One is how long we've been talking about humanoid robots. We've been talking about that for a long time.
There's some really creepy ones out there.
They're still creepy, but the thought of actual use cases and productivity getting harvested from humanoid robots, it's just really cool to see that. But one thing we do forget about automation in general is a need for verticality. Like the square footage is something everyone talks about as a problem in manufacturing. Like, so it's hard to expand. So being able to go vertical is very important. So like the warehouse, AMR or AMRs autonomous robots machines that you'll see, scooting stuff around. At some point, it's got to go vertical. You have to pick it up and put it on a conveyor at some point. And I think that's one of the scenarios we see is these humanoid robots, solving the problem of going vertical to the next layer in automation. And actually, I've seen a lot of use cases where if you see a lot of mills together, you have a cell that's linear, transferring part from one cell to the other, obviously you could have a robot on track. Or I've seen a lot of interesting use cases where the robot's mounted above the machine to save floor space. So going vertical, again, definitely is beneficial. So that's two interesting observations. Hopefully works out well. But I agree with you. It's not the supplemental of humans to make them more efficient. Seems like an interesting use case. And I'm curious to see where Amazon might go with the exoskeletons too, because I feel like that's a branch that they can get into.
Well, I mean, obviously, there's also been a lot of critique on Amazon for how they treat their warehouse workers. So maybe this could also be their way of kind of problem solving that too. Of like, instead of all humans having to work the overnight shift, it's some humans and some robots. And I think, I think working at AMT, it's really opened my eyes to the fact that like robots really aren't taking people's jobs.
It's interesting that you mentioned that. So the problem they're trying to solve is, instead of treating humans like robots, let's just put robots in there.
Yeah, exactly. And, so don't expect people to be the people to be the robots. Expect the robots to be the robots. So, I mean, I see it as a good thing, but I can see why people are critiquing it. I can see why people are like, but like I said, I mean, they've been using robots in their warehouses for like 11 years. So this is just kind of an extra layer to that, I think.
Definitely.
Yeah.
Awesome, guys.
I think AI and robots are probably going to be like one of the safest technologies humans ever come up with.
Because we're so scared of them.
Because we are terrified of them. And we've been terrified of them since like before they've even been close to being deployable en masse.
Yeah.
So the thing I've noticed with automation is there's definitely a different progression of, let's talk about the safety standards before we look at. So the safety standards related to automation, that's fairly robust. Like you're doing risk assessments, defining who owns the risk. I don't see much being done on artificial intelligence, particularly ones that are more agent-based or decision-making for you. So I don't see the risk assessment and safety thought process being done on the same way.
That's going to come down to regulation on the tech companies. Because the biggest threat to AI is the fact that what the biggest threat was when ChatGPT went mainstream. All of the big tech companies that were bigger than OpenAI. I mean, who had ever heard of OpenAI before? As soon as OpenAI emerges as like a potential competitor to the big tech, like Mexican standoff, if you would. It's like, what do you think Google, Apple, Microsoft are going to say when this big disruptive product comes out and they don't have one? They're going to rush theirs to market, and they're going to, how do you get something to market faster? You skip steps. What steps to making a good AI should be stepped? Well, good is subjective, but what steps can speed up the development of an AI? Let's skip state safety.
And that's
there's no regulation that we can follow, that we can track to say that Microsoft, Google, or Apple has been safe at all in the development of their AIs.
And I do think that's one thing that we need to be a little more cautious of how we talk about it. So like in industrial applications, the AI is very, very focused. So we do like a vision application of like measuring or training a model to say, is this good or is this bad? That's very, very focused. But these wide scale, like commercial applications where using large natural language models or asking questions, that's where the concern comes in, because it's such a broad spectrum of use cases where it is tough to put safety guards on, because Chat GPT does have some safety protocols when you ask it essentially dangerous questions, but it's easy to trick.
Right.
And
Yeah.
that's where it's just such a broad tool that they developed where it's hard to come up with every single use case that can be safe around. And that's where you see the difference in industrial applications, because it is significantly more laser focused on industrial applications where you can put safety applications
Right. And can you manipulate safety to get something unsafe?
Right,
Like
right.
what should I avoid? Dear ChatGPT, what should I avoid mixing with ammonia and bleach to not die while trying to clean a bathroom? It's like, please don't mix ammonia and bleach. That's how you make mustard gas. Thanks.
That's why you don't clean a cat box with bleach.
Oh, good point.
But lastly, before we go, with all this talk on automation and safety, and the death of a technology, I think we've already touched on the fact that we don't think additive is going anywhere anytime soon. Right. If anything, it's just gonna come out more once it's integrated with the industry. But speaking to automation and safety, are we witnessing the death of the Cobot?
No.
There's a new ISO standard that was just released that redefines what is a Cobot.
Right.
That I certainly need to read up on to see what changed in the new standard. But will the Cobot term and collaborative robots continue to be a term used in our industry?
Let's talk about that next episode. I think
this is something worth looking into.
Agreed, because we've been talking about that in the automation committee quite a bit, and we got some thoughts.
Excellent. Cool.
It's like a to be continued.
Ramia?
Yeah.
Where can they find more info about us?
amtonline.org/. Like and subscribe.
Bing bong.